She is Dr. Jill Tarter, and she has one of the stranger jobs in the world. She looks for alien civilizations.
I'm a radio astronomer that's working on a very unique search, trying to listen for radio signals from distant technologies. I usually don't say that I'm looking for little green men.
She works for the SETI Institute. SETI is the search for extraterrestrial intelligence. And on this day, the searchers have come to the National Radio Astronomy Observatory in Green Bank, West Virginia.
The most fun part of my job is being able to get some time at the telescope to observe. So this one takes you east and west. Actually, most of the observing is done from our offices back in Mountain View. We run this remotely, and the operators here at the telescope help us. So it's a real pleasure to get to the telescope itself.
If you've seen the movie Contact, you may feel you've met Jill Tarter before. She's a lot like the radio astronomer Jodie Foster played in the film.
There's 400 billion stars
and only
out there.
two probabilities. One, there is intelligent life out there, but it's so far away you'll never contact it in your lifetime. And
you're making a decision.
Two, there's nothing out there but noble gases and carbon compounds, and you're wasting your time. In the meantime, you won't be published, you won't be taken seriously, and your career will be over before it's begun.
So what? It's my life.
The character of astronomer Ellie Arroway was created by Carl Sagan and his wife Anne Druyan for the novel Contact. She's not Jill's exact counterpart, but there are similarities.
Well, it's funny. I had an interesting conversation with Carl back in '85. I was at Cornell for another meeting, and he invited my husband and myself up to the house. And we had a conversation, and he said, "I'm writing this book." And Andrian said, "Well, you may think you recognize somebody in the book, but I think you'll like her."
Like Ellie in the film, Jill Tarter is brilliant, driven, and a bit obsessed.
Guilty as charged. What can I say? You do get to be a little bit obsessive about this kind of work. You have to have a passion for it, or you wouldn't stick with it.
After she earned her doctorate in theoretical astrophysics, she has worked on various SETI projects for NASA and the University of California.
I was pretty much a nuts and bolts kid, but I had a father who loved astronomy, and I'd walk along the beach at night with my dad, and he'd point out the stars, and I just loved that time. And I'm of an age that I grew up with Saturday morning cartoons, sort of Flash Gordon, Saturday morning television programs. And so I don't think there was ever a time when I didn't suppose that the stars out there were suns for other people.
But of all the young people who grew up with Flash Gordon or with Buck Rogers, or with 100 B-movies about creatures from other planets, very few went on to actually search for people under other suns.
That part worked.
And those who did found a public fascinated by the subject, but a government that wasn't. In 1978, a senator gave the search for life on other worlds a Golden Fleece Award for wasting taxpayers' money.
Well, NASA did have a SETI program that got a new start in 1989, was on the telescope for the first time in 1992, and then was terminated by Congress a year later in 1993.
The SETI researchers would have gotten $12 million a year out of NASA's $14 billion budget, but even that was too much.
In the case of SETI, however, the chances of success are so remote and the likely benefits of the program are so limited that there is little justification for $12 million taxpayer dollars to be expended for this program.
So Jill Tarter's SETI Institute is funded privately. If she wants to use the government's big radio dish to listen for signs of life beyond Earth, she stands in line with other researchers and rents the place for $6,000 a day. For that, she gets to sit in a cramped room in the base of the antenna, listening to the motors that drive the big dish and waiting for her screen to tell her what truth is out there. You are here on a small planet revolving around a middle-aged star out near the edge of a huge swirl of stars called a galaxy. Look up. On a clear night, you can see probably 2,000 stars, just a few of the 400 billion suns in our galaxy. You can see a lot more of them with the Hubble Space Telescope. But pick a little spot between the stars and you'll find other galaxies. Everywhere you look, there are more islands of stars floating in the dark universe. There are probably 50 billion other galaxies, each with hundreds of billions of suns.
That means there are more stars in the visible universe than there are grains of sand on all the beaches of the Earth. And to think that this is the only grain of sand where something interesting is happening, where life is happening, where intelligent life happens, that would make us so incredibly special that astronomers are very leery of that thought.
In 1961, astronomer Frank Drake tried to estimate the number of technological civilizations in our galaxy and came up with an educated guess that is now called the Drake equation. It makes it into all the SETI books and even shows up on souvenir t-shirts. Start with the number of stars in the galaxy, some 400 billion. For life, you need stars with planets. As recently as 1995, we hadn't found any. Then, astronomers started using new equipment that could measure the slight wobble of a star with planets. They found planetary systems throughout our galactic neighborhood. The Space Telescope even photographed a planet of a star in the constellation of Taurus.
Our planet's really a dime a dozen in the universe. Recent discoveries have shown that at least 3 or 5% of all stars have planets, and the real percentage is probably much higher.
But how many stars have planets with liquid water? Out of the 9 planets in our solar system, 3 were once wet. But now only the Earth has oceans.
In our solar system, there's at least one planet where life can cook up. That's the Earth. So let's say that solar systems have at least one planet where life can cook up.
How many actually have life? That's a tough one. We only have life on Earth as an example, and all that life is related.
Life on this planet seems to find wherever it can go, it'll creep in and make a living for itself. But that shouldn't deceive us. Life on this planet is one specimen of the phenomenon of life. There may not be any others. If we are the only specimen of life anywhere in the universe, then the origin of life, the kind of chemical event we're looking for, has got to be a very, very improbable event indeed.
But on the other hand, life sprang up early in Earth's history.
We don't know how life got started here. We don't really know. But if we were to find that there really was once life on Mars, that would tell us right away that, gosh, life's not a miracle, it's just a statistic. Every time I give you a planet that's halfway decent, life will cook up. If you're the optimistic type, then you'd say, well, probably 50 or 100% of those planets will cook up life.
The next thing we need is intelligent life that invents technology.
If you have a bunch of intelligent critters on another planet, sooner or later, science will spring up. It will occur to them because there's a tremendous advantage to your society if you can understand science.
Say 1 in 10 develops radio technology. Then 2 billion civilizations in our galaxy could have sent out radio signals. But are any of them still around?
The final term in the Drake equation is, well, how long do they stay on the air? Right? What fraction of time do they broadcast? And that's really unknown.
The invention of radio technology and the invention of weapons of mass destruction seem to go hand in hand.
So maybe what happens is E.T. gets on the air, he's sending us messages, and then bam! Big mushroom cloud, that's it. Well, if that's the general way of things, then we're not going to hear anything, because E.T. won't be on the air long enough. But if you're optimistic and say that E.T. will stay on the air for at least 1 million years, then the number of broadcasting civilizations in our galaxy is on the order of tens of thousands. Tens of thousands.
Say it's 40,000 civilizations among 400 billion stars. Why haven't we heard any transmissions from other civilizations?
It'd be like asking Chris Columbus two days out of Spain, well, when are you going to find something? He doesn't know, and we don't know either.
The science people say it's just a matter of finding that one star in 10 million. But the science fiction people say, if the Drake equation is right, aliens should be here by now.
But it's likely our descendants will travel from star to star slower than the speed of light in great big spinning colony ships that take generations to get to another star, plant a colony, and then spend generations building up their industry, building more starships and sending them on. If that happens, calculations now indicate it would take our descendants 60 million years to fill the galaxy. Now that sounds like a long time, but it's an eye blink in the history of this slowly turning galaxy of ours. So the question then becomes, why aren't they here already?
Possibility 1. Civilizations are too scattered to make contact.
The idea of how long intelligent life can be sustained and how likely it is that our little speck on the spectrum of time will coincide with another intelligent life form speck so that we can find each other is fascinating and frightening and discouraging, I'm afraid.
Possibility 2. No other civilization developed technology.
We might go out there and find lots and lots and lots of aliens, but they're dolphins, they're octopuses, they're strange watery creatures who never got off their planet. We meet and shake hands to tentacles with lots of other beings to talk to, but nobody would push us around because we'd be the ones with the starships.
Possibility 3. Other civilizations have technology, but no curiosity about the rest of the universe.
We may go out there and find a lot of stodgy, old, curmudgeon civilizations that need to be taught a little fun.
Or maybe the aliens know all about us, but want to keep us on the reservation.
What if we're being kept ignorant of a civilization out there because they love our art, they love our TV? And as soon as we know about them, we'd be able to assert our rights and demand a copy of the Encyclopedia Galactica. In which case, I am now formally, they can pick up our radio waves, I am now formally, in the name of humanity, demanding entry into the Galactic Federation.
Sorry.
The motion picture camera had just been invented when aliens took a starring role. By the 1950s, there was an extraterrestrial invasion on our screens.
Invaders from Mars. Weird, fantastic beings of a superintelligence.
Today, envisioning extraterrestrials is a game, a sport, and an industry.
And guys, you could all help with the flippers and all that. It should really go big.
The effects are better, the aliens more elaborate, and the money bigger than ever.
And action.
Fire on 3. 1, 2, 3.
In 1997, Men in Black grossed over $580 million.
Zoom up a little bit.
And action!
Hollywood is the world's center for extraterrestrial creation.
Look at the camera, don't move.
It may sound kind of twisted to think of this as cute, but what we tried to do was incorporate kind of like chubby thighs and a big belly.
I have 3 girls. They sort of take it for granted when they talk to the kids. What kind of monsters does your dad make, you know? They assume that everybody has a dad that does this kind of thing.
Alec Gillis and his partner Tom Woodruff have created giant insects for Starship Troopers, a cross between a reptile and a wasp for alien resurrection, and an alien that grows inside human bodies for the X-Files film.
And feet all kind of pulled up in a little
We look at a lot of reference material. We will go to museums or zoos, depending on what the character, what the challenge is. But the overriding drive behind any of our design work is it's got to look believable and it's got to look cool. And our feeling is if you stay grounded to some sort of reality, you will always produce something that's much more believable.
Hollywood aliens have ranged from blobs to bugs. But lately, our screens have been taken over by a particular type of extraterrestrial, a creature bald and gray.
Now, it used to be that aliens tended to be little green guys, maybe with 3 eyeballs, but in the last couple of decades, actually, the grays have taken over in the popular imagination.
Should I know?
They've got these large eyes, which are alien, and yet they seem intelligent and wise and knowing. And they've got these big heads, like they are smarter than we are. They know more than we do, which is also kind of reassuring. And then they're physically not threatening. They're very small bodies and very, awkward, spindly arms and legs, and they suggest, again, sort of a superior being.
Chrissy, can you recall where you are?
I'm in a room on a spaceship, surrounded by aliens.
What do the aliens look like?
They're small, but their heads and their eyes are big. They're gray.
As part of the desire to make the show seem real, seem like it could be happening, we wanted to use the classic image of gray aliens that everyone knows, that is deeply rooted in the popular imagination for whatever reason.
The Greys were popularized by Whitley Strieber's book Communion and have been popping up in films, tabloids, and TV ever since. Many people claim to have met these aliens. A recent poll found that 64% of Americans believe extraterrestrials have contacted human beings.
They're not from around here, no. By no means.
One of the contactees is Dennis Laird. He met his alien on February 14th, 1976.
The being was quite tall. He was, within inches of being 7 foot tall, and very big head, big arm and eyes, and he had long fingers. His fingers were probably, 9-10 inches long. And he had very wide shoulders. He was a very wide guy, about like Yave, for a normal person. But when he turned to walk out, he was only this thick. He was only about 5 or 6 inches thick.
Small bodies, big heads. These aliens do not load trucks for a living. I mean, these guys, they sit in front of a monitor and do computer work all day or something like that.
Why is this form of alien so popular? Maybe because the Greys are what we think we will be someday.
They're really only a projection of our fears. I mean, they have big eyes, big heads, no hair. No hair. Well, that's just a projection. We're losing our hair. These guys are way ahead of us. They've lost their hair. Small noses, well, we don't smell much anymore. These guys are ahead of us on that. Small mouths, same deal. We're losing our dentition.
It saddens me that the image that so many people have of aliens is this smooth-domed, big, black-eyed, long fingertip creature that's on the covers of so many books and magazines. Its behavior is precisely the same as elves in the Grimm's fairy tales. Not a single UFO episode I have ever heard of, if it were true, described the behavior of grown-ups.
Do any of the aliens in popular culture make sense? Not to astronomer Shostak.
The aliens I see in the movies, of course, are kind of like winter vegetables. There isn't very much variety. You had the Blob many years ago. This was a giant single-celled critter whose only function in life was to eat us. It was sort of a single-celled piranha.
Boy, that was close. Hey, come on.
But that doesn't make sense. A single-celled creature can't be very intelligent. You need lots of cells to be smart.
Rolling. Speed.
Hey, Mark.
And why do the current crop of evil aliens in the movies look like reptiles or insects?
A million years ago, when our ancestors were smaller and furrier and living in the trees, snakes could get up into the trees and eat our young. So we have a natural fear of snakes, reptiles, insects, and Hollywood knows that, and the bad aliens tend to look like that.
But back in the real world, one alien hunter won't even guess what her quarry looks like.
I guess I don't have much poetry in my soul. Just detecting the signal is a big enough challenge for me, and I don't care what they look like. I don't care what they eat for breakfast, whether they're green, blue, purple, or how many sexes they have. Just knowing that somewhere else, physics and chemistry put together another sentient creature with the ability to build radio telescopes is a big enough payoff for me.
You might be surprised to learn that we have found life on another world. It happened on November 19th, 1969.
P-64, Pete. Traffic and go for landing. Roger.
The Apollo 12 mission. Apollo 12 landed near Surveyor Crater, and that crater was called Surveyor Crater because the Surveyor spacecraft, a robot spacecraft, had landed there almost 2 years before. The astronauts were able to land within walking distance of the Surveyor spacecraft, take a few pieces of it off and bring them back to Earth. And when the exobiologists looked at the camera on Surveyor, there were Streptococcus bacteria inside of it. Those weren't moon bugs. The spacecraft had been imperfectly sterilized. They'd been carried to the moon, and they had survived there.
When researchers gave the bacteria food, they promptly began to reproduce. They had survived freeze-drying and the hard vacuum of the moon. The point is, we're just discovering how tough and adaptable living things can be. They found lichen in the rocks of Antarctica. Bizarre tube worms clustered around volcanic vents at the bottom of the ocean. They found bacteria contentedly munching on rock 5 miles beneath the surface.
On Earth, we've learned in just the last decade that there's a whole biosphere of microorganisms that live subsurface. In fact, the mass of that biosphere might even exceed the mass of the entire surface biosphere that we see day in and day out.
And then there's the Mars rock. Researchers in Antarctica found a meteorite that had been blown off Mars billions of years ago by a colossal explosion. The rock made headlines in 1996 when it was found to contain chemical signs of life and tiny structures that looked like fossilized bacteria. The debate over the Mars rock was still going on when the Pathfinder probe landed on the red planet. The little rover rolled up to some rocks and discovered that they were once underwater. This whole plain was once covered with a sea the size of the Great Lakes.
Down under that rusty, dusty surface, there may be liquid water, and there may be some sorts of microbes that are still alive on Mars today. It's probably not very smart, because living underground there, it's probably going to be rather small, microbial, as they say.
Small enough to hitchhike on rocks, making the journey between Earth and Mars.
These two worlds have been exchanging rocks for 4 billion years, and sooner or later you'd kind of think somebody might get lucky. And then you have to ask, if there was an origin of life on Earth at about the same time that Mars had liquid water flowing on its surface, and that sure looks like the case, is it possible that Earth life colonized Mars. Could even have gone the other way. It could be, it's not out of the realm of possibility that our ancestors originated on Mars, were carried here by Martian meteorites to a place where the environment was going to be stable for much longer.
In which case, we may be the extraterrestrials we've been looking for. Now, NASA is studying another water world in our solar system, Europa, a cracked cue ball of a moon circling the planet Jupiter. The Galileo space probe sent back close-ups of the cracks and ridges in its icy surface that could have been caused by warmer, liquid water underneath.
Europa may be the most hospitable place for life in the solar system. Europa may have the other ocean of our solar system, and the volume of that ocean is probably about the same as the volume of the Earth's ocean.
There could be life there that's had possibly billions of years to evolve. Well, there's some pretty intelligent life in our own oceans. I mean, think of the dolphins, the whales. For that matter, octopi and squids are pretty sharp too. Now, mind you, they don't build tools, they haven't constructed radio transmitters, but it's conceivable that there's some fairly intelligent life in those inky dark seas of Europa.
And that's just the beginning. There are all those newly discovered worlds out there.
In addition to our own solar system, we've learned that planets are common in our galaxy. We've seen protoplanetary disks where solar systems are forming, indications of nearly 10 more solar systems besides our own, and there's every reason to expect that there are many more. All of this has come together in just the last 10 or 15 years. And of course it's having an impact on the way we think about further exploration, and that impact can be seen perhaps most clearly in the decision by Dan Golden of NASA to put new resources into this field.
The one thing NASA isn't doing is participating in the radio search for extraterrestrial intelligence. No one at the space agency wants to brave the wrath of congressional budget committees.
Suppose we were aliens on a nearby world. Could we recognize that there was life on Earth?
It's a key question. How do you go about finding an alien civilization? How would an alien go about finding us? Visual observation wouldn't work very well.
Detecting life by looking for engineered structures, things that we built that look artificial, it's really chancy. Looking at all of the pictures that have been taken by the shuttle, the great majority of them show no evidence of our engineering, our presence on this planet.
If our alien was close enough to Earth, he might whip out his spectroscope.
So all you have to do is sort of analyze the light that's reflected off the Earth, and you'll find this spectral signature, the telltale signs of things like methane and oxygen. You know, most of the oxygen in Earth's atmosphere was probably made by blue-green algae. So that would tell you that there's algae. Most of the methane was made by what's politely called bovine flatulence and pig flatulence. So, you know, you could find pigs in space this way.
And you could find pond scum this way, but that's still a long way from discovering a technological civilization. Anyway, that kind of atmospheric analysis is impossible at interstellar distances. But there's another way to check out a star, at radio wavelengths. The quickest way to find us is to aim a radio telescope in our direction. An alien would instantly pick up a storm of television, radio, and radar signals.
That would only work if you were relatively nearby, because our earliest powerful broadcasts are only 40 or 50 light years from Earth now, so you'd have to be within that distance. Tune a radio receiver or TV receiver and pick up I Love Lucy or Mr. Ed or something like that. But you could detect life on Earth from the other side of the galaxy if you had a big enough telescope.
Signals we sent into space in the 60s are just reaching the star Arcturus.
What's that?
If there are any radio telescopes there, a freckled wooden puppet is announcing that there is intelligent life on Earth.
Oh, well, howdy doody, boys and girls.
Tune an FM radio between stations and you hear a hiss. Mixed in with some noise from the radio's amplifier are signals from the stars.
You're actually listening to the Milky Way. You're listening to electrons that are spiraling around the magnetic field lines in the Milky Way, so you can actually hear the galaxy on your radio.
There's a lot of interstellar hissing on radios in the town of Green Bank, West Virginia. Radio stations and television transmitters, for that matter, are banned in this area because it's the home of the government's National Radio Astronomy Observatory.
The radio telescope is constructed in this valley that's ringed by mountains in order to help protect it from transmitters that we're using for other purposes. When this was built back in the early 60s, it was important to find someplace that was naturally shielded, and it was, in fact, by law mandated to be a radio quiet zone, so there cannot be any active transmitters within 50 miles of the observatory.
Radio astronomers use dish antennas like these to study the universe. They pick up natural radio waves emitted by everything from galaxies to stars to single hydrogen atoms floating in space. That's how we discovered pulsars and quasars and mapped the surface of Venus. The Green Bank Radio Telescope has a dish 140 feet across, and the new one under construction will hold a football field. The antennas have to be big because the signals from the stars are so faint.
These are really weak signals. Someone calculated that if you took all of the radio waves that had ever been collected and you took the energy that was represented by those signals, it's equivalent to the amount of energy that's released when a snowflake falls to the ground. Lots of cackling and hissing. Basically, noise is most of what we're receiving.
Yeah, go ahead.
When the SETI Institute gets its chance to use the scope, the first order of business is to mount a 1-ton receiver at the focal point of the dish. To minimize the noise of the electronics, the device is cooled with liquid helium to a temperature of 11 degrees above absolute zero. You can tell when the search for extraterrestrial life is underway at Green Bank. There's a shielded steel van full of signal processors and computers plugged into the back of the telescope. The project is named for the mythical bird that arose from its own ashes. Technicians can spend all day hooking up the phone booth-sized receiver only to find that it's not working. So they swing the dish back down, climb the service tower, and start taking things apart.
Is that blue or yellow?
Black or dark blue, I'm going to be shining down at black.
Okay. Look at both of them. I don't see anything.
The operation can be brought to a standstill by a dirty optical fiber.
Good. We got light there, Gary.
See the light.
Want me to hook them back up?
And that cuts into Jill's observation time.
From Green Bank now, we've looked at something over 210 stars. That's where we were when I started the run yesterday. We actually observed 6 more stars last night. We're going to look at 1,000 stars with this search. They're all very nearby. The most distant one is 155 light years from us. The observations that we're doing here, if you cover the entire frequency range that we look at, it takes 12 hours to finish up a star.
No one knows the exact frequency extraterrestrials might be using. But there is a naturally quiet area in the radio spectrum, near the frequency of hydrogen atoms. Any logical alien would know what we know. That's the best place to send a signal. SETI's receivers and computers divide the quiet area into 1 billion channels. They listen to each channel for 1,000 seconds. The telescope is exquisitely sensitive. It could easily find a single cell phone on Mars.
It's just a few photons that jiggle a couple of electrons in a transistor, and then it gets hugely amplified.
The huge amplification means that there are false alarms. When observing with a single dish, there's 1 chance in 30 that random noise in the equipment could show up as a signal.
But we just got one of those 1 in 30s. What happened was that it detected a signal. It went off source. It didn't see the signal, not seen off. And then it went back on source and didn't see the signal again. Now that's either an extraterrestrial who decided to talk to us for only less than 1,000 seconds, or it's in fact the fact that we operate with the single telescope only at a 1 in 30 chance of noise triggering a detection.
The operator can watch the progress of the search on a screen, but computers do a lot of the work, monitoring 28 million channels at a time. When something is detected, the computer moves the dish off target and then back on to make sure the signal is really coming from that part of the sky.
Spacecraft primarily are our problem, because we're sitting here at what's the world's only radio quiet zone. There should not be any transmitters in the area for 50 miles. On the other hand, it doesn't extend 50 miles up.
And that can be a problem.
We're starting to draw this huge curve, which is actually is now up to 50,000 detections. Oh, that's ugly. It's ugly. Okay, I may want not to observe through there again. I mean, I know when I'm defeated, I cannot build a piece of hardware that will detect a single faint signal and that hash at the same time. It was a wideband frequency modulated signal. I suspect it was just telemetry from a spacecraft.
Tartar's equipment looks for artificial signals, and it finds them.
Oh, it detects technology extremely well. Unfortunately, it's our own. So far.
The same scientific laws apply to everything and everyone in the universe. So there are some things we can say about an extraterrestrial.
About all you can say is, well, he'll probably follow good engineering practice. We've assumed that ET will grow up on a planet that's not so different from our own Earth, because you need liquid water, so you need the right temperatures, you need the right gravitational field. All of that speaks to a planet that's not so different from the Earth.
Something equivalent to genes is absolutely a must. That's not even an adaptation. I mean, that's the prerequisite to the whole thing. And my suspicion is that it's likely to be digital, as DNA is. It's got to be very, very accurate, and only digital codes are that accurate.
He'll be multicellular. You need small cells, but in order to do anything interesting, you need a lot of them. You need a complex machine. That means that ET can't be smaller than a pinhead or larger than 20 elephants put together, because there are mechanical reasons why that isn't going to work very well. Or in the case of a very small critter, it's not going to be very smart. There aren't enough cells in there to make them very smart. Okay? So that says something about the size.
Eyes have evolved independently at least 40 times around the animal kingdom on this planet. So my guess would be, if there's life anywhere else, perhaps eyes are a relatively likely thing.
Limbs, you need to get around. You know, you can imagine animals that had wheels, but that isn't going to work very well unless the planet comes with roads already built.
Legs have evolved many times. Wheels have never evolved, apart from in technology.
How many legs do you want? 2, 4, 6, all that would be easy. But if you have 600 legs, now your brain is spending a lot of time coordinating all those legs instead of, doing other things like figuring out how to build a radio transmitter or a rocket. So ET probably will have a small number of legs.
And ET will need some limbs adapted to holding tools.
What you need is some sort of manipulative appendage, an opposable thumb or a trunk or something that allows you to modify your environment, to create a technology.
You'll have a head. A head's a useful thing to house your brain and put all your sense organs near the brain, so your brain doesn't have to wait to get information from the sense organs, things like that.
What if aliens have discovered what's called nanotechnology, the ability to make microscopic machines that can go into their bodies and give them, in effect, immortality? Some people think that we will achieve this within just 20 years. What if you could just, with your thoughts, reconfigure your body, order it to grow a rebreather lung so you could dive under the water and stay under there? If these technologies are possible, we may find that aliens can reconfigure themselves pretty much at will. Not instantly, like in Star Trek, but in ways that we would find very akin to what we used to think the Greek gods were like. After all, we are like gods to our ancestors.
The real aliens are going to be way ahead of us. So if you can understand it, they'll tell you things that are interesting, like how to get along, what's the cure for death, here's some physics.
But actually, the most clever alien is not one that's been depicted in movies, but it was in science fiction, and that was Fred Hoyle's Black Cloud, an animated cloud of plasma. So it was far different than humans with 2 hands and 2 legs.
What's really out there will ultimately depend on how long a technological civilization lasts. Russian astronomer Nikolai Kardashev thought that given enough time, there might be 3 levels of advanced civilizations. Type 1 civilizations would have harnessed the power of the atom, about the place we are now. Type 2 civilizations might make use of the total energy output of a star. Maybe they've taken the planets apart and moved the pieces into a shell around the sun. And then there's the 3rd type, a civilization that has learned to harness all the energy of a galaxy. Almost unimaginable, but space is a strange place. Biologist J.B.S. Haldane put it this way: the universe is not only queerer than we suppose, it's queerer than we can suppose. We can only guess how the discovery of extraterrestrial life would change things here on Earth.
I think the most important thing about detection of an extraterrestrial signal from another civilization would be that it would change our viewpoint, change the viewpoint of humans. We begin to see ourselves as one species on one small planet in a very large universe occupied by others. And I think we'd have to be enormously impressed by the differences between us and anyone else out there. And I would hope that what that would do for us would be to diminish the differences among humans that we find so difficult to tolerate today, and that it would give us this global or cosmic perspective that would make humanity function as a single entity.
So, in a halting way, at Green Bank and Mountain View and Arecibo, the search is on. And the radio astronomers watch their screens and get ready to celebrate the moment we discover we are not alone.
Every place we observe, there's usually a refrigerator, and in that refrigerator you'll find at least 1 bottle of champagne.